Hi YouTube, Timothy Unkert here. In this video, we're going to solve two quadratic equations using the quadratic formula. One quadratic equation will have real solutions, and the other one will have complex solutions. And I'm going to show you on Desmos what this looks like graphically. So let's get started with the first example. We have solve for x, and we have this 3x squared minus 9x equals -1. And again, we're going to use the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac, so 4 times a times c, all over 2a. Okay, and this is for a quadratic of the form ax squared plus bx plus c equals 0. Okay, so this quadratic, we have 3x squared minus 9x equals -1. We have to get one side equal to 0 so before we even start. So I'm going to add 1 to both sides here. And on the right-hand side, if I add -1 to +1, well, I get just plain old 0. And on the left-hand side, I can't add 1 to -9x because they're not like terms. I also can't add 1 to 3x squared because they also are not like terms. So this just becomes 3x squared minus 9x plus 1, and that's equal to 0. Okay? So now we want to identify a, b, and c so we can plug those into the quadratic equation. So a is the number in front of x squared. That's going to be 3. B is the number, and we call that a coefficient. So this is a coefficient, this is a coefficient. The number in front of x is -9. And then c is the constant term, that is the number by itself, so c is 1. Okay, so now what we need to do is just plug this into the quadratic formula. So I'm going to say x equals, well, when we say -b, we just changed the sign of -9 to +9. So we have 9 plus or minus the square root of -9 squared minus 4 times 3 times 1. And that's all over 2 times a, so 2 times 3. Okay, so let's start to simplify this. So x is going to still equal 9 plus or minus, well, -9 squared is positive 81 because -9 times -9, that gives me a positive number. So positive 81 minus 4 times 3 times 1 is 12. And on the bottom, we have 2 times 3, which is 6. So x is going to equal 9 plus or minus. So 81 minus 12, that's going to be 69 over 6. Okay, so let's do some math here. So 69 is divisible by 3. If we divide 69 by 3, well, 3 goes into 6 twice, and then we bring down the 9. So 3 goes into 9 3 times, and we're not going to have a remainder here, a remainder of 0. So 3 times 23 is 69, so we really can't simplify that too much. So really our two solutions are x equals, now you could make this 3 halves plus square root of 69 over 6, but I'm going to leave it on the top here. So I'm going to say 9 plus the square root of 69 over 6, and x equals 9 minus the square root of 69 over 6. All right, so let's come up with an estimate for these numbers. So uh, x in this case is going to be approximately, well, what's the square root of 69? The square root of 64 is 8, and the square root of 9 or 81 is 9. So it's somewhere between 8 and 9. It's a bit closer to 8. So, maybe it's like this is like 17.3 divided by 6. So it's a little shy of um, of, well, 18 divided by 6 would be 3. So let's take a guess, maybe 2.85. Now this is just a guesstimate, quick rough guesstimate. Well, we'll check this out in the graph in a moment. So here we have 9 minus 8. So this is almost, it's like it's less than 1/6. So 1/6 is 0.16. So let's say it's like 0.13. So x is approximately, and then again, I'll be a little bit off on these, but I'm just quickly doing the math here. Obviously, these here are the exact answers. You want to have the exact answer, not just some guesstimate that you do in your head. We're now going to check these out on the graph of Desmos. So this should be the leftmost x-intercept for the parabola. The parabola is going to open up because we have a positive 3 in front. And this is going to be the rightmost x-intercept, so the larger x-intercept. So the way I'm going to do this is I'm going to actually, on Desmos, I'm going to graph the equation y equals 3x squared minus 9x plus 1. Okay, so I'm going to graph that on Desmos, so let's go to Desmos. Okay, I'm at Desmos, so let's graph this. So we've got y equals 3x squared minus 9x plus 1. Okay, so we see it crosses at 0.116. I said 0.13, so I guessed it was slightly high. And then 2.884, I said 2.85, so pretty close on both of those. But yeah, so with the two real solutions, we have two x-intercepts. And you'll see in the next example with the complex solutions what that means, so stay tuned for that. Okay, in our second example, we have this quadratic equation 10x squared minus 2x plus 9 equals 0. We want to solve for x. This is already in the form ax squared plus bx plus c. So let's just identify a, which is 10, b, which is negative 2, and c, which is 9. Okay, and so we'll plug into the quadratic formula. So I'm going to say x equals negative b, so the opposite sign of whatever b is, so positive 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 10, times c, which is 9. And this is all over 2a, so all over 2 times 10. Okay, so now we get x, if we continue to simplify, x equals 2 plus or minus the square root of negative 2 squared is 4, and then 4 times 10 times 9 is 4 times 90, so that's minus 360, over 2 times 10, which is 20. Okay, so now keep going. We got x equals 2 plus or minus. 4 minus 360 is negative 356. Okay. So that is a bit divisible. We can break that down. Okay, and this is, let me show you how I'm going to break that down. So x equals 2 plus or minus. Well, we can pull out a negative 1. and that's going to be an imaginary number. I'll show you that in a minute. And then 356, let's divide that. Let's see if that's divisible by 4. So let's go into 4. So 8 times 4 is 32. And then you're left with 36. So that's 89. So subtract 36, and we get 0. Okay, so it's -1 times 4 times 89. Now 89, if you add 8 and 9, you get 17. So that's not divisible by 3. This is all over 20. And not divisible by stuff like 7 or 11. So we're just going to leave square root of 89, but I can take out this -1, and the square root of -1, let's make a note, square root of -1, you can't have a number times itself that would equal -1. So we represent that in mathematics with an I, and that stands for an imaginary number. And imaginary numbers are actually used in real world applications, but yeah, so let that blow your mind a little bit. But and then square root of 4, let's do that in a different color. Square root of 4 is 2, right? So when I pull out the 4 and the -1, I get 2i. Okay, so I'm going to have a 2i that I can take out of the square root, and I'm just left with the square root of 89. So let's continue to simplify that. So we've got x equals 2 plus or minus, and then we're going to have 2i, because we've taken that out, square roots of 89, all over 20. Now, both 2 and 20 are divisible by 2, so if I divide a 2 out of the top and the bottom, I get x equals 1 plus or minus. Now, you can't do that. Since 2i is multiplied by the square root of 89, if you divide out the 2 here, you don't want to divide 89 by 2. That's something different. Yeah, let's just avoid that. So we have 1 plus or minus I square roots of 89 over 10. Okay, so these are complex solutions, meaning you have a real and imaginary part of the solution. So one of our solutions is x equals 1. Let's do the smaller one. 1 minus I square roots of 89 over 10. And then the other one is x equals 1 plus I square roots of 89 over 10. So what does this mean graphically? Well, let's jump to Desmos. Okay, so we're at Desmos, so let's plug in the equation. We'll say y equals 10x squared minus 2x plus 9. Okay, so we're not seeing this anywhere, and it has a 10 in front, so it should open up. But let's zoom out, and oh, look at that. Here is our parabola, and the lowest part of the graph, the vertex, is at 0, 9. So what does this mean? Well, if we look here, we see that right here is our x-axis. We are never crossing the x-axis, so when you have two complex solutions, your quadratic never crosses the x-axis. If there were a negative in front, what the parabola would do, it would open down somewhere. So if you have a negative number in front, it opens down. Positive number, it opens up. But if you have complex solutions, they never cross the x-axis, so you never have any x-intercepts. Hopefully this video was helpful to you. If it was, please like and subscribe, and thank you for watching the video.